In this video, we're going to be looking at the processor. The processor is a vital part of a computer system. We will look at three areas: the purpose of a processor, the components which are contained within the processor, and the fetch-decode-execute cycle. A processor is a small chip which connects to the motherboard. Its job is to be given instructions and complete them. It also manages all other hardware in a computer system. We can imagine it as being very similar to a list of jobs to do. On that list of jobs to do, you write down things that you need to do and tick them off as you complete them. The processor is given instructions to complete, it completes them and moves on to the next one using the fetch-decode-execute cycle. There are many components which are contained within the processor. The first part we're going to look at is in the green box. The registers are locations where data and instructions can be stored. There are two types of register. The first one being general purpose, where any data or any instructions can be stored. The second type is special purpose. Again, data and instructions can be stored in these locations. However, that data and instructions represents certain things which are needed by the processor. The first one is the program counter. Its job is to point to the address of the next instruction to be executed in memory. Imagine you've got a task list of 5 things that you need to do today, and watching this video is task number 3. The program counter could be said to be pointing to the next thing you need to do, task number 4. The memory address register is a reference to the location in memory of where an instruction is stored. This can be used to make sure that we load the correct instruction at the right time. The memory data register is a location in main memory which contains an instruction or data which is vital to a fetch-decode-execute cycle. The current instruction register contains the instruction which is currently being executed, and the accumulator contains the results of any processing which has happened already. The other two components of the processor are the control unit and the ALU, arithmetic and logic unit. The control unit is in charge of executing instructions in the correct order. It also decodes instructions and manages communication between other hardware components and the processor. The arithmetic and logic unit completes 3 types of operation. Arithmetic operations include mathematical functions such as add and subtract. Logical instructions include and, or, and not, amongst many other logic gates. And shift operations, which involve moving the bits of a binary string to the left or right to multiply or divide a number by 2. The buses that you can see in the centre of the image are in place to manage moving data from one place to another in the computer system. Collectively, these 3 buses are known as the system bus. Memory is a place where we store data and instructions. We can see it as having 2 parts. The first one being an address, which is just a reference to a place in memory, and the data or instruction which is stored within that location in memory. All of these components work together when completing the fetch-decode-execute cycle to ensure that tasks are completed. The fetch-decode-execute cycle has 7 steps to it. The first thing that must happen is the address held in the program counter is copied to the memory address register. Remember that the program counter points to the next instruction that is going to be completed. So to begin the fetch-decode-execute cycle, we get the location of that instruction from the program counter and put it into the address register to represent the instruction we are about to complete. The next two instructions, or parts of the cycle, complete in tandem. The program counter is incremented to make sure that it's pointing to the address of the next instruction. At the same time, the data held at the location referenced by the memory address register is copied from memory and placed into the memory data register. Following on from that, the memory data register has its data copied to the current instruction register. At this point, most of the data from main memory has been fetched, if not all of the data. In the decode phase, two things happen. The first one is that the instruction in the current instruction register is split into an opcode and an operand by the control unit. The opcode represents the instruction which is going to be completed, whether we're going to load, store, add or subtract data. And the operand is the data or the location of data which we are going to be using. Imagine that you've got an instruction which is add 6. The opcode or instruction to be completed is add, and the operand in this case would be 6 because that is the data we are going to be working with. Following on from that, any additional data is copied from memory into the memory data register. And that is only if the operand is a reference to a location in memory. The final part of this cycle is execute, whereby the instruction is completed by the processor and any operations, which are mathematical, logical or shift, are completed by the arithmetic logic unit, and any results are stored into the accumulator. This cycle repeats throughout the execution of a computer. I've wrote the instructions in shorthand here. This is a far easier way to revise the key parts of the fetch-decode-execute cycle. You may wish to quiz on this to make sure that you've got the key points that happen within the cycle. I'm now going to show you how the fetch-decode-execute cycle would complete a set of instructions. On the left-hand side of the screen, you can see how the memory looks at the moment. And on the right-hand side of the screen, there is a trace table which I will fill in with you now. At the start of the fetch-decode-execute cycle, we do not know the values which are contained within the address register, the data register, the instruction register, or the accumulator. The only thing that we know at this point is that the program pointer is pointing to location 1. Let's trace through the fetch-decode-execute cycle now. The first thing that happens is the program counter value is copied into the memory address register. We then increment the program counter value and bring the data which is held at the address referenced by the MAR into the MDR. So this data here, which is in address number 1, is going to be copied to here. The next thing that happens is the data in the memory data register is copied across to the current instruction register. In decode, we split that data into the opcode and the operand, and we fetch any additional data that we need. In this case, we need to load the data from number 6 and bring it across to memory. That will go into the accumulator in this case. We then repeat the process. We copy the program counter value into the memory address register. We increment the program counter by 1. We bring the instruction across, which is going to be to add 5 to our accumulator value, I'm putting the hash there just to show the difference between memory locations and raw data that we're using. We then copy that across into the current instruction register. And the control unit will split that into the opcode and the operand. The instruction is then executed, and so 5 is added to the accumulator value and stored back in the accumulator, giving us 17. The fetch-decode-execute cycle goes again. We copy the program counter value into the memory address register, increment the program counter, and bring our instruction from the memory into the memory data register, which in this case is going to be to store the data in location 5. That gets copied into the current instruction register. The control unit splits that, and the instruction is executed. In this case, we're not actually altering the value in the accumulator, so I'm going to leave the end box blank. What I will do though is take the value from the accumulator, 17, and store it in memory location 5. We then repeat the fetch-decode-execute cycle, copying the value from the program counter into the address register, incrementing the program counter, bringing our instruction across to the MDR, moving that across to the instruction register, decoding it and executing it, stopping the program. Pause the video now and have a go at tracing the instructions in memory through the fetch-decode-execute cycle. To begin with, we do not know the values which are in the address register, the data register, the current instruction register, or the accumulator. We just know that the program counter is pointing to address number 1. Let's begin the fetch-decode-execute cycle. To begin with, the data in the program counter is copied to the memory address register. The program counter is incremented by 1 to point to the next instruction, and the instruction is copied across to the memory data register. In this case, it is to load from location 5. We copy that instruction across to the current instruction register. The control unit then splits that, and we execute the instruction. I'm hoping you didn't fall for the trap here and load 27 in. There is no data in location 5, so I am going to write 0 in the accumulator. We then go on to the next round of the fetch-decode-execute cycle. We copy the value from the program counter into the memory address register. Increment the program counter to point to the next instruction, and bring our instruction across to the data register, which is to subtract 10. I'm going to put a hash in front of that just to make it clear that that is not a memory location. The MDR is then copied to the current instruction register. We decode the instruction. We don't need to fetch any additional data, and so we execute the instruction. The ALU would do this by performing 0 minus 10 and would store a value of minus 10 in the accumulator. We then go again. The program counter value is copied, incremented, and the instruction is brought across from main memory. This time we will be storing in location 5. That is copied across to the current instruction register. And the value in the current instruction register is split by the control unit into the opcode and the operand. We're not actually altering the accumulator value this time. We are simply storing the value that we've created over in memory. So I'm going to write minus 10 in memory. We then complete our final round of the fetch, decode, execute cycle for this program. We copy the value 4 from the program counter into the address register, increment it, bring our instruction across, copy it from the data register into the instruction register, decode, little mistake there, we decode it and the program would stop at this point. Remember that the fetch, decode, execute cycle is repeating itself throughout the time that a computer is operating. I hope this video has helped you to understand the different components in a processor and the fetch, decode, execute cycle alongside its purpose. Thanks for watching.